OSPF special area types are fun. Matter of fact, even creating this slide was awesome. I was writing up understanding stub, totally stub, and my wife happened to look over my shoulder as I'm doing that, and she goes, come on, what? That's not real. And I said, seriously, they have areas that are really, no, we kind of went back and forth because I'm always doing something goofy. So I'm here now to prove to my wife that these are truly real areas in OSPF. The majority of OSPF implementations will have what I call normal areas. Essentially, it all starts with area 0. It's the backbone. Routers completely immersed in an area, whether it be area 0 or area 2, are considered internal router, meaning they don't have interfaces to other areas. This one's special because it's also called a backbone router, because it's in area 0. These guys connecting between areas are ABRs, area border routers, and this guy connecting outside the system, ASBR. These are normal OSPF implementation. And I just finished building a GNS3 implementation that dreams are made of. This took me forever to build, but it's awesome. It's worth it. So I went ahead and deployed OSPF in this. This, as of right now, is a normal OSPF implementation. I'd say outside of this guy right here. This is an area not connected to area 0. So in order to make this work, we would have to have a virtual link. I'll probably do that in a forthcoming nugget because I don't think we'll have the time in this one. So I just want to grab a router. Let's go to router 7, right? Just get a lay of the land, and you can see when I come in here on router 7, do a show IP route. We've got OSPF routes coming in. We've got the external routes. You can see the redistributed routes from outside the system. We've got inter-area routes that are essentially representing the routes. You see 172.30, area 23 routes over there from other areas. I mean, pretty normal. So let's talk special. The special OSPF areas are really geared around optimizing routing tables. Take a look at the network diagram in front of you. We've got area 0, the backbone of the network, connected over here to area 2 and area 1, just normal areas, passing through an area border router, router 2 and router 5. Router 3 is an autonomous system boundary router connected to the cloud, whatever that is. Maybe it's a RIP network with 1,000 routes. That'd be awesome. Redistribute those into the OSPF system. So there's our scenario. So hang on, you might look at this and be like, okay, Jeremy, what is this really? I mean, I see the colorful circles. Maybe this is PetSmart. I actually met with the network engineer of PetSmart some time ago. This is kind of their network design to where they have a corporate office and they connect all their pet stores. Essentially, PetSmart, a pet supply store. They have, I get fish from there when I shop for my fish tank, but they have all these little stores all around the United States. So maybe this is the Arizona office major router, if you will, and it connects to all these little strip mall PetSmart stores in Arizona through a frame relay connection. At least that's where they used to be years and years ago when I spoke to the network engineer. That was the design. So it could be something like that. So backbone area, you can see right there, we've got area 0. Standard or normal area would be considered area 1, area 2. Let's talk about the first one, the stub area. The stub area is designed around the fact that all these routers in area 2 don't really benefit from getting the external routes. I mean, think about it. We've got RIP redistributing 1,000 routes in there. Does router 1 really care about all those routes? I mean, honestly, you might say, well, yeah, doesn't he have to reach them? Well, yeah, but does he need all the specifics? I mean, does he have to have 1,000 routes, or could he just have a default route saying, you know what, everything that I don't know about, send to router 2, and let router 2 take that burden. Maybe we buy a little beefier router for router 2, and it can handle a larger routing table where all the routes in area 2 just have a default route for the RIP routes out there. That is the description of a stub area. And to understand the technical piece of that, you've got the LSAs. LSAs stand for link state advertisements. Essentially, you may remember from another nugget in the route series that I talked about LSAs being like a baseball trading card. So you've got the 10.1.1.0/24 network. Its LSA would have its stats. You know, this is the next hop. This is the cost of that route. This is the time that I've known about that route. Essentially, all the detail information about that route is considered in the LSA. And a normal LSA is considered an LSA type run. That's what every router generates for every single network that they know. By the way, you might remember you shove those into an envelope called an LSU and send it to your neighbors, right? The link state update. So LSA type 2 is generated by the DR. If you remember a DR and BDR, those are the routers that essentially sit on a shared network. The routers send their type 1 LSAs to the DR, and the DR says, okay, I'm going to let everybody else know about those. That's going to be a type 2 LSA or something that the DR generates, advertising itself. Now, this is where we get into the LSAs that are impacted by the special area types, type 3, 4, and 5. A type 5 LSA is considered an external route. So when the ASBR redistributes these 1,000 RIP routes, every single one of those 1,000 RIP routes is going to get its own little LSA, but it's going to be a type 5 LSA that says, okay, let's just say that one of the RIP routes was 172.16.1.0, right? So it will be a type 5 LSA advertising all the stats of that network. When it comes to router 2 says, hey, whoa. I've been configured as a stub area, and stub rules say no LSA type 5s are allowed. So that's, I mean, whether you're talking the technical or just human communication, whether you say type 5 LSAs are blocked or you just say external routes are blocked, it's the same idea. That's what a stub area does, and automatically generates a default route. So as soon as you tell router 2, Area 2 is a stub area, it automatically generates a default route for all the routers in there. That is one of the flags, though, by the way, for OSPF neighbor relationships. The command, and matter of fact, let me show this to you. I'm gonna go over to my turn caps lock off first off. Come over to my GNS3 world. Let's make area 23 a stub network, right? So before we do, I'm gonna go over to router 3 there, and let's do a enter, show IP route. Right, so we've got router 3. He's seeing the inter-area routes, right? And he sees some external routes there as well. So if I go into router 3, this is, by the way, this is a one command. All routers have to have the flag that's in the area. I'll go router OSPF 1, area, what area are we in? Area 23. Stub. That's the story. Now you can see neighbor just went down, and the fact is he's not coming back up because they now have a stub flag mismatch. If I do a show IP OSPF neighbor, you can see neighbor is he's just dead. So I'm going to come over to router 2 and match that configuration. He, by the way, is the most critical piece because he's the ABR. Did I have that cut off at the bottom? Hopefully not. He is the ABR of the system. So I'm going to go in there and do router OSPF 1, area 23 stub. All right. Now that he's on the same page with stubness, right? Router 3 is like, oh, okay, we can be neighbors again. Sweet. So now, okay, again, get a snapshot view right here. Previously, he had these external routes. Those were the type 5 LSAs. Now what happens? Show IP route. And those are gone. All he sees is the inter-area routes, but notice what is new is an OSPF default route. You can see a little star right there. It represents the default route, automatically generated by the ABR of the system. Pretty awesome, eh? Now, Cisco went to a whole new level, and they were like, hey, if we've got stub, and Cisco being based in California and all, they're like, we are going to go totally stubby. And you got to say it like a Californian. Totally stubby, dude. Now, totally stubby, by the way, Cisco created it, so it becomes Cisco proprietary-ish. Hang on, hold the phone before you're like, throw it out the window because it's Cisco proprietary. The only device that has to be a Cisco router is router phone, router 4. And you can't say Cisco and speak at the same time or you'll spell it wrong. This has to be the Cisco router. All of these can be heathen routers. Right? Because they can be whatever brand they want because all they have to have is the stub flag. It really is just the stub flag. Just the ABR is configured as the totally stubby. And okay, I'm going on and on and on. What's the difference? Totally stubby cuts off not only external but also inter-area routes. Right? Again, I mean, the logic totally makes sense. Why does if router 5 doesn't need to know about these guys, then why does he have to know about these guys and these guys as well? I mean, why does he care if a network goes up or down or need advertisements about that? Because he just has one way to get out there anyway, or he has a single kind of entry-exit point of the system. Let's make router 5 fast by optimizing his routing table. So watch this. Router 5. Show IP route. Right now he's got imagine thousands and thousands and thousands of routes, right? I'm going to go into router 5 and do router OSPF 1, area 45. Area 45 stub. Notice I'm using the same command. I'm not doing anything special because, again, the specialness has to happen over here on router 4. Router 4. Router 4. There you are. Router 4, I'm going to come up here, and here's the specialness. Router OSPF 1, area 45, stub, no summary. That is how you do a totally stubby area, and it totally makes sense too. Totally. Because no summary represents no summary routes from outside the system. By the way, Type 3 LSA represents a summary route. So much to say. Type 3 LSA right here doesn't mean a route is necessarily summarized, although it could be. Just remember, ABRs are the routers that can do summarization. These are just routes that come from outside the area. Even though they're called summaries, they're just routes from other areas. They could be summaries, they might not be. But Type 4 LSA is an ASBR location. This guy sends a special message saying, hey, everybody, here I am. Right? Here's the cost to reach me. So both of those are going to be cut off. So now let's go check out router 5, right? Notice neighbor reset. Come out here and do that show IP route again, which you can see right above a whole bunch of routes. Show IP route now. Bam! Nothing. Router 5, you're nothing. Now he's down to nothing, 000, nothing but a default route, which again was automatically generated by the whatever router that was. Right there, router 4, which acted now as that stub no summary, that totally stubby Cisco proprietary router. Everything else can be whatever brand you want. The last one I want to talk about is a not-so-stubby area. I know what you're thinking. You're like, that's totally proprietary, right? No! Believe it or not, some industry standard maniac named this area not-so-stubby area. What is it? Well, it's a stub area that grew too big. Again, imagine, I'll go back to my PetSmart scenario. Let's just say we got all these stores, and for whatever reason, let's just say PetSmart does a hostile takeover of Petco, and this is the only way that they can connect to Petco, is they have Petco, which runs EIGRP, and now needs to send routes through this, but this was previously configured as a stub or totally stubby area. What you can do is you can configure this as a not-so-stubby area, which allows you to redistribute routes through that area into the rest of the system. Now, think about that. That alone is messed up because the whole idea of a stub and totally stubby area is that it blocks, both of those guys block Type 5 or essentially external routes. And what did you do? You connected your router in that stub area to an outside system, and now you are defying the whole name of why you have a stub area in the first place. That's why they call it a not so stubby area, is essentially you redistribute routes through there, and they have this special LSA type. It's called LSA type 7, right? All LSA type 7 is, it's like those Shakespeare mask. You ever see those things where it's like this big frown face or the happy face that you put in front of? Really, these are Type 5 LSAs, right? Get it? They're external to the system. That, I mean, they define what a Type 5 LSA is all about. But what it does is say, well, I'm going to put this little mask because the whole definition of a stub area is that it's going to block Type 5 LSAs. So let's kind of put these masks on those routes through. All these routers are like, what are you? Oh, I'm a Type 7 LSA. They're like, what's that? I don't know. Gets to this router, rips the mask off, and then they become Type 5 LSAs. So really, all Type 7 is almost like a tunneling LSA type, so that they can secret ninja-like get these EIGRP routes through the stub area. But when they get into the rest of the system, and they're like, okay, really, guys, we're just kidding. We are totally Type 5 LSAs, and then all the same filtering rules apply. If this guy over here is a stub area, he's going to block those and replace them with the default route because they truly are external. That's what a not-so-stubby area is all about. You now know so much stuff. You know about stub, totally stub, not so stubby areas, and the OSPF LSA types. I hope this has been informative for you, and I'd like to thank you for viewing.